Collision detection algorithms are used in games and computer graphics, and here is an example where Mario is travelling at some velocity to catch a mushroom and increase his level. So we can attach a sphere to Mario and a mushroom, and this will be initially accurate enough to detect a collision when the spheres overlap. So given that Mario and the mushroom each have a position xy relative to some fixed origin, and the radii of their spheres are r1 and r2. So these spheres collide when the distance between them is less than or equal to the sum of their radii. And using Pythagoras' theorem, we can construct the following right-angled triangle, and therefore D is equal to the square root of this horizontal distance, which is the difference between the x-coordinates of the centers of those circles. And we square that, then plus the square of that vertical distance. So that would be y2 minus y1 squared. And now we can write the pseudocode of the collision detection algorithm. So I have the inputs are the coordinates of the centers of these spheres and the radii of the spheres. So for Mario, we have x1, y1, and r1. And for the mushroom, we have x2, y2, and r2. And the output is going to be a flag, which is a true or false, that indicates whether a collision occurred. And we'll also output delta, because when these spheres collide, due to the numerical precision of the computer, the spheres can penetrate into each other. So in our first line of code, we're going to calculate the horizontal distance, dx, which is the difference between the x-coordinates of the centers of the spheres. And similarly for dy, we'll have this vertical distance, which will be y2 minus y1. And now we can calculate d, which is the distance between the centers of those spheres. So that will be the square root of dx squared, which is dx by dx plus dy squared. And in the next line of code, we calculate the sum between the radii of the spheres, which we'll call sum r1, r2. So that will be r1 plus r2. And in the next line of code, we check if the distance between the spheres is less than or equal to r1 plus r2. According to this equation, then a collision has occurred, and we set the output flag to true. And we can also calculate the penetration depth between the spheres by subtracting the distance between the spheres from the sum of the radii. Now otherwise, no collision occurred, so we set flag equal to false, and the penetration depth to 0. And finally, we return the value of the flag to indicate if a collision occurred and the penetration depth between the spheres. Now you could have also written this square root as sqrt, and you could have also compared the squared distance between the spheres to the square of the sum of the radii to detect a collision. Because most of the time collisions don't occur, and calculating the square root can be expensive. Please subscribe, like and comment to help me reach more students.